Hi guys, on the previous video I think we went through implementing Azure Functions using Visual Studio Code. We saw that the process took time to create resources and all of that because it was creating I think a resource group, then it created an app service plan, then it created a storage account, then it created app insights, then it created the actual function, then it deployed the function code. But then when we're trying to access the function code on Azure, it was giving some issues. I don't know if my Visual Studio Code had to restart or something. Anyways, enough about the rant. Here, if you are new to the videos, all I can say is if you are writing your AZ2 4 or you want to understand more of this content, please read the description below. I make sure that I write, fully detailed descriptions unless if it's just an exercise or something of some sort where I'm just implementing something. Then in that case, I don't write much. I just give you a link to the Microsoft side of things versus what I implemented. So this content, because you can see it's going to be theoretical, I write notes below so that you can, if you don't like me mumbling, you can listen to me for 5 minutes or so, read the notes, understand the notes, copy them if needs be. That's not a problem. The intention here is for us to learn together. If you find this content very useful, you can recommend it to someone else, and voila. So cool. Where are we now? We are now done with Azure function apps. Now we are in Azure durable functions, right? Durable functions enable you to write stateful. This is what makes them durable. Stateful functions in a serverless compute environment. Then here we say explore durable function app patterns. Durable functions enables writing uh, orchestrator functions and stateful entities by writing entity functions using Azure Function Programming Language, right? So you can write stateful functions or orchestrator functions that are stateful uh, by using certain entities within the Azure Functions programming model. The extension provided the extension provided provides managing state, extend checkpoints, and restart for you in the background, right? So what happens is we have extension methods that are provided. This extension methods allows us to one, manage state, two, manage checkpoints, three, manage how the what you call orchestrator function actually restarts and all of that. The supported languages for this particular durable functions is C Sharp, JavaScript, Python, F Sharp, and PowerShell. I don't know how PowerShell, but PowerShell, yeah. Primary use case for durable functions is simply complex. Okay, primary use case for durable functions is to simplify complex stateful coordination requirements in a serverless application. So what is it? Is the primary use case for durable functions is to simplify complex and stateful coordination requirements in serverless applications. So what does that say? This, I think, needs to be rephrased somehow. So used for solving complex and stateful coordination requirements in serverless applications. I think that makes sense a bit. Yeah, you never know what happens. Typical application patterns that can benefit from durable functions. So you have the ability to do function chaining. You can do fan in, fan out. You can have asynchronous HTTP APIs. You can have for monitoring. You can also use durable functions for human interactions. So for human interactions, basically it's for workflows that require human interactions like manual approval. Let's say, for example, you are working in a department where there's a job order that gets sent to, let's say, your what do you call, I don't know, your supervisor, and your supervisor has to approve that job order, and you get that job order back. It gets assigned to an employee. So using durable functions, we are able to wait for that particular supervisor to respond so that we can send or create whatever that we need. If they reject the job order, we don't create a job. Say for example, if they accept it, we create a job or assign it to someone in the team. So monitor, it's for recurring processing that constantly checks for state changes. So let's say, for example, we have an application that constantly check if a state changes. Then we could use durable functions to constantly check that state. Once the state changes, we do whatever with the state change event, essentially. And asynchronous HTTP APIs. So this is for long-running HTTP actions or activities. So think about this in a sense of, let's say, for example, we have a job that effectively updates our database to some degree, or does some maintenance on our database. So it will typically be difficult to have that type of implementation going on. So what would happen is, would effectively run that in a durable function. It will manage stage. It will know where it is. Once it gets over the, sorry about the audio. Once it gets over what do you call, a certain threshold, it will restore its state and all of those type of activities. Then here we have fan out or fan in. So fan out is when, let's say for example, one application now triggers, let's say 10 functions on the next level. Those 10 functions do some sort of aggregations parallel. Then after that, we want that information to actually go back into one function that aggregates all the results and then sends it out to create or to make a decision. So the first part, send into multiple functions, that's fan out. Then when multiple functions needs to now put their results into one function that does the final comparison or final decision, that's fan in. Then function chaining is when we have a process that is well defined. Well, let's say for example, the before you, I'm thinking of a process that makes sense. So before you let's say make your cereals, you typically do the first function, which is take out the bowl, or the first function check if there's actually cereal. Once the cereal, open the fridge, check if there's milk. That's the second function. Once this what you call milk and the cereal, take out a bowl from the cupboard. That's third function. Fourth function then says, okay, now that the bowl is outside, now rinse the bowl. That's the fourth function. Pour cereal, pour milk. Then I don't know if the cereal is ready, consume it or not. Those type of things would be a function chaining. So all those functions, because you had me calling them out, we would have one orchestrator function that says, okay, I'm gonna call a function that says take out cereal, then check the fridge, then check the milk in the fridge, then take out the bowl, rinse the bowl, put the cereal in the bowl, mix it with milk, stir, whatever. You'd have an orchestrator function that does the chaining essentially. Then code examples of the above pattern. Here's a link, which is good. This is function chaining. You see there's function 1 that gives an output, and after function 2 then uses that function 2 uses the output of function 1 to compute. Its output is used by function 3. Its output is used by function 4. That's function chaining. Fanning, one function creates an output. Its output is consumed by multiple functions. Those multiple functions aggregates their outputs into one. That one output from multiple functions comes into what do you call one function. So this is fan out. This is fan in. Cool. Then this is the asynchronous call, where I didn't explain this one on code. I think I did actually. So you have long running processes that could run over and over and over. Then here we have a get state type of functionality. Once this gets the state, essentially what happens is it will update the state or use the state to do something along those lines. Monitoring, as we said, is a continuously recurring type of function. It sends in information, reads in state, or does whatever type of functionality it requires. Let's say, for example, It will receive it as and when people are walking through, I don't know, a gate. It will keep on logging consistently until such a point that we stop the function. And based on who walked in, it can take a decision to notify, I don't know, security or whatever the case might be. Human interaction type of thing, that's what I was talking about. Approval escalate is one of the other examples. Polio. So here you see they have an orchestrator trigger that triggers a function. That's the function to approve. So an orchestrator triggers that. On this particular one, there's an orchestrator involved as well, passing in a context. Then what do you call? It triggers a function there. This one, HTTP start. What's the HTTP start related to? This is that one. Just a normal function with a durable client there, which is the starter. So it calls the starter, check status, da da da. Then fan out, fan in function, it has an orchestrator there. Then it runs the task parallel on this particular level. Then it checks if all the tasks are complete, then do the sum with the results there. That's a fan out, fan in type of situation. Then this is chaining. So call one, then call two, then call three, using the output of one, compute the results of two, using the output of two, there compute the result three, using the result of three, compute the final result. That's chaining. Folio, discover four function types. So the four function types that we have is orchestrator function, activity function, entity function, and finally client function. What is the client function? A client function is a function that uses durable client output binding, right? It uses a durable client output binding. Output binding. Then entity function for reading and updating small pieces of state. They have special trigger type called entity trigger. Uses entity ID to access and execute operation on entity. Activity functions. These are basic unit of work. Unit of work does not have restrictions such as orchestrator. Can be used for compute intensive tasks. Can only have a single value passed to them. Then orchestration functions. This one defines how actions are executed, orchestrates between different functions, processes, outputs, and other sub-orchestrators. So you could have an orchestrator being orchestrated by another orchestrator. So this would be an orchestrator inside a parent orchestrator. Code for this type must be deterministic in nature. So you should be able to read the code and see what's going on essentially to have a proper orchestrator. Cannot trigger an orchestrator of entity function directly from the Azure portal, but needs to actually trigger a function that triggers either of the two. So you cannot trigger an orchestrator or an entity function on the Azure portal, right? You need to trigger a function that triggers those things. Orchestrator and entity functions are triggered by messages enqueued in the task hub. Because the task hub that enqueues messages, that's what triggers those two. Explore task hub. Not sure if I'm gonna do justice to that topic, but yeah, let's go for it. Explore task hub. Task hub. Nope. Let's cut the video there. I'll continue on this later. How I feel about this. Okay. Yeah, no. Let's skip it. I'll do this one in another video. Thanks, cool guys.